Thank you very much, Bob. Morning, everybody. I'm Tom Clark, MD and founder here at Ocean Array Systems. Our core product is software for simulation and control of wind and tidal turbines. We have a couple of key USPs. On the technical side, we can characterise and simulate atmospheric turbulence and its effect on wind turbines. On the commercial side, we can offer that simulation as a service, which is scalable, and it allows us to guarantee consistent, best-in-class analyses. I'll talk more about those benefits in a minute, but first, let's look where the pain really is in the industry, what the market drivers are, and what our business is really about. I'll give you a clue, it's not software. It's about risk. Gusting in the wind, unsteady flow and turbulence literally vibrates turbines to pieces. It's highly damaging, fatigue rates are extreme, and so far the phenomenon has been mostly unpredictable. Last summer, Ocean Array Systems won Santander's National Business Plan competition, placed third. That got us talking to their project financing team. You know, to fund a wind turbine, they swallow all this uncertainty, which is wrapped up as a cost of risk. That profoundly affects the cost of energy from wind, and sometimes even whether projects are viable at all. To reduce that risk, you need to know upfront when things will break and how turbines are going to perform at the specific site you're looking at. And that's what Turbine Grid is for, our software. It includes the effect of turbulence tailored for a specific site. It doesn't need supercomputers to run it, and it captures all of the snap loadings on blades and chaotic effects that are causing so much concern amongst clients like Siemens, General Electric, and Vestas. Just as important as all that, you know what? It's easy to use because we sell it as a service. Clients can upload input files to our servers to describe the turbine, select the test cases they want to run, and a little while later, just download the database of results. Simulations are guaranteed to be done according to best practices, and there's no bureaucratic process. Maybe we'll acquire this big piece of software in next year's budget. You just pay for runtime on a virtual test turbine as you need it. Easy. So how do we do this? Let's look under the bonnet. Site developers usually collect a lot of data, flow speeds and the like, but can't get turbulence information out of it. Our novel methods use standard data sets to create a virtual environment that's specific to the site, including turbulence, and simulate turbines within it. That really helps to reduce risk up front. But the benefits don't just stop there. You see, we can take those results and reuse them to train our artificially intelligent control systems. Those are modules that sit on board turbines, operating in real time along with the control systems to reduce damage and extend lifetimes. We've nearly finished a project with the Carbon Trust, which has really been helpful in validating and demonstrating our characterization process. We've filed 2 patents as well, one covering the method and the other covering the real-time AI technologies. The next step is a project to validate the software and showcase the AI systems. We're progressing well with technical development, and at the same time, we're developing our routes to market quite well. We've reached first revenues, and we'd like to open even more doors. So if you're interested in the space, we would love to talk to you. We're especially interested in software houses, looking perhaps to exploit this market as well, and potential clients, OEMs, site developers facing these issues with unsteady loadings. We feel like your advice and perspectives can really help us in delivering this next project and bringing this needed product to market. Finally, thanks so much to Cleantech Innovate for the opportunity to be here today, and thank you all for your time. We're looking forward to questions afterwards. That's Ocean Array Systems.